This is part 3 of our video on operations with logarithmic functions. So for this question, it says for the functions a of x equals log base 3 of x and b of x, which also equals log base 3 of x, determine a simplified expression for a plus b of x 2 different ways. And those 2 ways are collecting like terms and using log rules. So we're going to see if we can do a plus b of x. So a plus b of x is really a of x plus b of x. And then we are simply going to substitute a of x and b of x into our expression. So I have log base 3 of x, that's a of x. And normally when we substitute something in, we put it in a bracket. But this is just one term. It's not log base 3 of x and then plus something or minus something. This is one singular term. It's a monomial. So I don't really need a bracket because it's just one term. And then b of x, that is log base 3 of x. It is also just one single term, so it doesn't really need a bracket. But you could put one in if you wanted to. So we are collecting like terms. Are these like terms? Well, they have the same bases, they have the same arguments, and they don't really have a visible exponent, so they fit the criteria for like terms. So I have one log base 3 of x here, and I have another log base 3 of x here. So together, I have 2 log base 3s of x. Now, if you're having trouble trying to sort that out in your brain, you could think of it that there is a little invisible coefficient, sorry, I'm just trying to find a colored pen here, of 1. This is 1 log base 3 of x and 1 log base 3 of x, and 1 plus 1 is 2 log base 3 of x. We're just adding the coefficients together. Okay, we're going to try the same question, this time log rules. So I'm going to skip writing the a plus b of x and just start with the a of x plus b of x. So this is a of x plus b of x. And I already know that a of x is log base 3 of x. And b of x is also log base 3 of x. Now it is asking me to use log rules. So I'm going to pull out my little piece of paper that has all my log rules on it. I notice we have 2 logs being added that have the same base. So when I have 2 logs being added with the same base, we can combine them into a single function by multiplying their arguments. So I would do that this is log base 3 of, and then I would multiply x times x. Well, x times x is x squared. Now, I could put the square here outside the bracket. I could also put the square inside the bracket. It doesn't really matter. It is on the argument. It's not on the whole log, it's just on the argument. Okay. So I notice that these are not currently the same, which is weird because I added the same things together. But I do have another log rule here that says that log base b of x to the n is the same as n times log base b of x, so that we can take our power and bring it down out front and make it multiplication. So this square is really on the argument, so I can bring that 2 down out front and say that this is 2 times log base 3 of x. And I got the exact same answer, but I did it 2 entirely different ways. One where we collected like terms, and one where we used log rules. So we will have questions where we collect like terms, and we will have questions where we use log rules, and we'll talk as we're doing questions about how I know when to use one versus the other. All right, so I am going to see you in the next video to look at question number 4.